Hey guys, welcome to chapter 6. This is the first of our remote learning lessons, these screencasts. I'm sorry that I'm not there in person and we're not together in person, but we got this. We're gonna do this. We can do this. Okay, so here's a little bit of background about chapter 6. Chapter 6 is on matrices. Very straightforward. If there was ever a chapter that I would have chosen to teach remotely, this would have been it. Okay? You are actually the luckiest of all my classes. Let's just put that out there. Okay. Chapter 6 obviously starts with 6.1. However, our book, although we've never looked in there, has a chapter 0. In chapter 0, each section is an introduction to a different chapter. And these clever little math folk, the way they did it is lesson 6 in chapter 0 is an introduction to chapter 6 in the book. So when I say here 0.6, that's exactly what I mean. This is chapter 0, lesson 6. And when you do your homework, that's where your homework is going to be from. Okay, lesson 0. Okay, this lesson is super quick. It's basically just an introduction to matrices, what matrices are, what we can do with them, and so on and so forth. So without further ado, let's just go right into them. A matrix is basically a rectangular array of variables or constants, and they're arranged in rows and columns because that's what we math people do. We put things in rows and columns, okay? And matrices are enclosed in brackets, as you can see here. Now, inside the matrix, then, you're going to have different numbers, right? Different values. Each value in a matrix is called an element. Back in the day, they used to be called entries, and in some books, you'll see them, called entries. Now, we call them elements. Okay, so let's talk about the dimensions of a matrix, right? The dimensions of a matrix. So you know how we refer to dimensions of a room, let's say, right? We say this is a 5 by 4, right? Or if you want to talk about, like plywood or beams or whatever, we have 2 by 4s, and so on and so forth. Okay, that's how we refer to the dimensions of a matrix. But it's very, very specific, right? So you say the number of rows first, we usually say m rows, and the number of columns, we say n columns. M rows, n columns. And then we write it as, the dimensions of this matrix are m by n. That's how we read that, m by n. So rows first, then columns. Rows, then columns. All right, so look at this matrix here. Rows are the horizontal ones. So how many rows do I have? 1, 2, 3 rows. And I have 1, 2, 3, 4 columns. Okay, so this is a 3 by 4. Now, if ever there was something that mattered, this is it. Order matters here. Right? Because otherwise, if you say 4 by 3, it looks completely different. It's got 4 rows and 3 columns, and that's completely different. Okay? Now, each one of these elements has a name, right? It has a name that signifies the position it sits in. Okay, so for example, if instead of referring to you by your names when we were in our classroom, if I referred to you as, okay, second row, third column, right? That's how we refer to the entries here. Okay, so for example, this number here, this is in row 2, column 1. Okay, row 2, column 1. So how do I refer to that guy? Well, the entire matrix, as you see here, has a name given by a capital letter. This happens to be matrix A. So each of the little itty bitty entries in there will be designated as little a, okay? And then which row, which column does that -1 sit in? It sits in the first column. It sits in the second row, first column. Okay? So we call that A21. Hey, let's do another one because that was super fun. Let's do this one here. Okay? Where is this? This is in row 3, column 3. So that guy has a name A33. We don't do commas. We might do commas if, you have, let's say, more than 10 rows or columns, to distinguish, like 11, comma 1, right? That's when you might do commas. But in our class, in, most classes, we don't do that. Okay. So this is a matrix A right here. We want to state the dimensions of A. Well, this has 1 row, 2 rows by 1, 2, 3 columns. So it's a 2 by 3. And now it says to find the value of A23. Okay? Row 2, column 3. Row 2, column 3, that's -8. So you just say that's -8. Okay. What are some of the different types of matrices that we have here? Well, a row matrix, guess what that is, guys? It's a matrix with a row, with 1 row. So for example, that is a row matrix, okay? Hey, what are the dimensions of that? We've got 1 row, 4 columns. It's a 1 by 4. So guess what a column matrix is? It's a matrix with 1 column, like this one right here. Hey, what are the dimensions of this? 2 rows, 1 column, 2 by 1. Okay, a square matrix is a matrix that has the same number of rows as it does columns. Okay, so this one here is a 2 by 2. You could have a 3 by 3, a 7 by 7. You could even have an n by n. That's actually a rather famous matrix, n by n. A zero matrix is a matrix of any dimension with, you guessed it, every element 0. Okay? What's the dimension of this one here? 2 rows, 3 columns. That's a 2 by 3. Next, an identity matrix is a square matrix in which every element on the main diagonal is 1. Okay, what is the main diagonal, you ask? Well, in the matrix, what is the very first entry? This one. That diagonal that includes the very first entry, that is called the main diagonal. So in an identity matrix, the main diagonal is all 1s and everything else is 0. This is definitely an all or nothing deal. All of the main diagonal is 1. Everything else is 0. Okay? All right. All right, let's do some matrix operations. How to add or subtract matrices. First and foremost, matrices can only be added or subtracted if they have the same dimensions. This is the most important rule of today. Okay? So, right here, we're going to add 2 matrices, A and B. What are the dimensions of A? 2 by 2. What are the dimensions of B? 2 by 2. Oh, that means we can add them. The sum of A and B will also be a 2 by 2, right? The resulting matrix. Okay, so how do we do this? It's very, very easy. Okay, you take the first element of A and the corresponding first element of the second one, A and E, and you add them to each other. Then B and F and you add them to each other and you put them in the exact same spot. Okay? C and D, bottom left, right? C and G, bottom left, you add them and you put it bottom left. D and H, D and H, okay? And then when you subtract them, it's exactly the same thing. So you know what, without further ado, let's just go ahead and do this one. I have a matrix A, I have a matrix B, I have a matrix C. I want to add A plus C. Oh, not the same dimensions. Not possible. Okay? B minus A, hey, those have the same dimensions. I can totally do that. So you know what I'm going to do? I'm just going to copy over my matrix B minus my matrix A, and that's going to give me my new matrix. Okay? All right. So here's what we're going to do. I don't think I need a matrix that size. All right, so in the first position, I have basically row 1, column 1, row 1, column 1, 10 minus 2. I put it in row 1, column 1, 8. Next, you can go, to the left or to the right next or down. It doesn't matter. I'm going to go across. So this is the position, row 1, column 2. This is the position, row 1, column 2. I'm going to put it, guess where, guys? Row 1, column 2. Negative 2 minus 5. That's a negative 7, so that goes there. Next, row 2, column 1, row 2, column 1. It goes in row 2, column 1. Negative 3 minus negative 1. That's negative 2. Last but not least, row 2, column 2. Row 2, column 2 goes in row 2, column 2. 16 minus 3, that's a 13. And there you have it. You have just subtracted your very first set of matrices. Okay? All right, what's scalar multiplication all about? Scalar multiplication is when you can multiply a matrix by a constant. So in the world of matrices, the matrices are like the lords, the barons, right? Like they are the people who rule the land. Scalars are sort of that other people, okay? A scalar is basically a constant. It's a number that is not in a matrix. It's a lone number. Here, when you multiply a matrix by a scalar, each element in the matrix is multiplied by that number. So, easiest thing. So if you have, negative 3 times this matrix, I take negative 3 and I multiply everything in the matrix by negative 3. So this will be negative 3 times 1, negative 3. Going across, negative 3 times 5, negative 15. Negative 3 times 0. Negative 3 times negative 2 is positive 6. Negative 3 times negative 6 is 18. Times 4, negative 12. And there you have it. You get the same dimensions, right? Nothing else changes, and so on. Okay, properties. What rules can matrices follow? Well, matrix addition is commutative. So if you do A plus B, that's the same as B plus A. It's associative. So, like if you have to add 3 matrices, you could do A plus B first, then add it to C. Or you could do B plus C first, then add it to A. So basically you could do it in any order. Distributive property works. Let's just do a couple of examples and we'll see. I have a matrix A and I have a matrix B. I need to find 3 times A minus B. Now PEMDAS still works here, right? So you have to do the parentheses first. So here we're going to do 3 times matrix A minus matrix B. So that's going to be 3 times. If I subtract these, and I can because they're the same dimensions, and I'm going to get a 2 by 3. 5 minus 1 is 4. Going across, negative 2 minus 0. Negative 1 minus negative 2 is positive 1. Okay. 0 minus 3. 3 minus negative 1 is 4. 3 minus negative 1. And then 2 minus 6 is negative 4. Okay. Next, I need to distribute the 3. So I get 12. Just multiply everything by 3. Negative 6, 3, negative 9, 12, negative 12. And there you have it. Okay, okay. And of course, we can't do math if we can't solve equations. How do we solve equations? Let's solve a matrix equation. But first, let's remind ourselves what it means to solve an equation. Okay? If I have a cute little equation that looks like this, okay. All of these are numbers. 3 is a number, x is a number, 6 is a number. Basically, I add 6, 3x is equal to 6, divide by 3, divide by 3. X is equal to 2, okay? So what do we notice here? All of the players here were just regular old numbers. And when I solved for x, guess what I got for x? Another regular old number. So now, when I have a matrix equation, right, the variable in the equation represents a matrix. So when I say x equals blah, that blah is not going to be a number, it's going to be a matrix, right? So the solution will be a matrix, not a simple number. Okay, how do we solve matrix equations? First, just use algebra to solve for x. Notice that's a capital X. That's not a typo. Capital X stands for matrix X. Okay? That's not a number, that's a matrix. Once you've solved the equation for x, you substitute the given matrices for the variables other than x. Again, let's just do another equation. So, I have matrix A, I have matrix B. I am given the equation 2x minus A equals B, and I need to solve it for x. So first I take 2x minus A equal to B, and I need to solve for x, right? So what am I going to do? Add A. So 2 times capital X is equal to A plus B, or B plus A, whatever. Then I'm going to divide by 2. But what's dividing by 2? Is that the same as multiplying by 1 over 2? It sure is. So I say x is equal to 1 over 2 A plus B. Okay? That means now what I'm going to do, now that I've solved for x, I'm going to substitute matrices A and B. So x is going to be 1/2 A plus B. What's A? This matrix. Always put the brackets. Plus B. Oops. Brackets, brackets, close the parentheses. So x is equal to 1/2 times, adding -1 plus 5 is 4, -2 plus 0, -1 plus -1. 4 plus 4 is 8. 2 minus 6 is -4. And then we get 10. What next? Distribute the half. So what's x equal to? 2 minus 1 minus 1. 4 minus 2, positive 5. And there you have it. Okay? Alrighty. So a little bit about your homework. So first of all, the homework for these this unit, I've modified it a little bit. So it's actually not this. I'm going to, oh no, I'm sorry. This is the modified version. Oh my god, I'm so sorry. I did modify it. It is, you guys have no idea. It's very, very late right now. It's Sunday night, March 15. And I'm trying to get ahead of these things. And it's very, very late. I'm staying up like you guys stay up these days. Okay, so this is the homework, but here's what I wanted to say. Again, this is not a typo here. This homework is not from page 27. It's from page P27. So the way your book is, the way the pages are enumerated is, you know, you have page 1, page 2, page 3, but before that, you've got P1, P2, P3, and this is page P27, so it comes before page 1, okay? So the very beginning of the book. And you'll see there, it'll make sense because it'll be exactly what you've been doing here today, okay? All right, this was fun, guys. I will see you, well, when you watch this, the following day, and we can go over this. Thank you so much. And have a good rest of your day.